Hello everyone. So this is our module 1 topic, and today's topic is eigenvalue and eigenvector, and this is our lecture number 1.6, that is module 1 sixth lecture. Clear? So let's start today's topic, eigenvalue. First, eigenvalue. Eigenvalue. Question is, what is eigenvalue? Actually, in my last lecture I have told you what is characteristic equation, and also I have told you that the solution of a characteristic equation is called our eigenvalue. Clear? The solution of a characteristic equation is called an eigenvalue. Clear? So you can write a root of the characteristic equation of a square matrix let's say capital A, is said to be an eigenvalue. Clear? Eigenvalue, this is also called characteristic value. Okay, characteristic value. Clear? So remember, eigenvalue and characteristic value both are same. Similarly, eigenvector and characteristic vector both are same. So basic concept is, you will be given a square matrix. First of all, you have to find out the characteristic equation, then solve the characteristic equation, and you will get a root of the characteristic equation. Clear? If the matrix is of n order, so obviously the characteristic equation will be of degree n. Yes or no? Characteristic equation of degree n. Okay, in my last lecture I have told you that if the matrix is of n by n square matrix, then the characteristic equation will be of degree n. Okay, now tell me, if I solve this characteristic equation, then how many roots will be there? Obviously n roots. So this implies that for an n by n square matrix, there exist n eigenvalues. Yes or no? For an n by n square matrix, there exist n eigenvalues. They may be distinct eigenvalue, may be repeated eigenvalue. Okay, for example, let's say question, find out the eigenvalues of the matrix A is equals to 1 minus 1 0 1 2 minus 1 3 2 minus 2. Okay, this is your matrix A. So first of all, you have to find out the characteristic equation. Okay, so you know how to find out the characteristic equation. You have to solve determinant A minus xi. So solution, determinant A minus xi, this is equals to 0. So or determinant A minus xi, that means x will be subtracted from the diagonal elements. So 1 minus x minus 1 0 1 2 minus x minus 1 3 2 minus 2 minus x, and this is equals to 0. So if you find out the determinant, then you will get this is equals to 1 minus x into 2 minus x. Don't copy from my video, just pause the video and calculate this problem yourself. Okay, so 2 minus x into minus 2 minus x plus 2 minus minus 3 plus 2 plus x. This is equals to 0. Okay, so if I simplify this, we are getting 1 minus x into minus 4 plus x square plus 2 minus from here x minus 1. This is equals to 0. Okay, so obviously we are getting 1 minus x into x square minus 2 minus, if I take common 1, so this will be, if I take common minus, so this will be plus 1 minus x. This is equals to 0. So 1 minus x is common, so we are getting x square minus 2 plus 1. Yes or no? We are taking common 1 minus this one and this one, so we are getting x square minus 2 and 1 minus x is common, so from this factor you will get 1. That's why x square minus 2 plus 1, and this is equals to 0. So 1 minus x into x square minus 1, this is equals to 0. You are getting 1 minus x into x plus 1 into x minus 1, this is equals to 0, and this imply x equals to 1 comma 1 comma minus 1. Okay, so these are the solutions of the characteristic equations, and I have told you that the solutions of the characteristic equations are the eigenvalues of the equation, now of the matrix. Okay, so the eigenvalues of A are 1 comma 1 comma minus 1. Okay, I think it is clear. 1 comma 1 comma minus 1. Now, so eigenvalue is very easy concept. Yes or no? Eigenvalue is very easy concept. Just you have to solve the characteristic equation. Now come to the next topic, that is eigenvector. Very important topic, eigenvector. Okay, before going to the eigenvector, let me tell you two most important points regarding to the concept of eigenvalue. First one, remember the sum of eigenvalue is equals to the trace of the matrix. Okay, sum of eigenvalue, this is equals to trace of matrix. Trace means sum of the diagonal elements. Sum of the diagonal elements. Okay, if you want to verify this statement, you can see here we have three eigenvalues, 1 comma 1 comma minus 1. That means the sum of the eigenvalues is 1. Yes or no? So obviously the trace will be 1. That means the sum of the diagonal elements will be 1. You can see this was the given matrix, 1 2 minus 2, 1 plus 2 minus 2. This is our trace. Okay, obviously this is equals to 1. Clear? So for every square matrix, sum of the eigenvalues always represents the trace of the matrix. Clear? And the second point is product of eigenvalue, this is equals to determinant of the matrix A. Okay, product of eigenvalue represents the determinant of the matrix A. Here what is the product? 1 into 1 into minus 1, that means minus 1 is the product. Okay, if you calculate the determinant from here, you will get that 1 into minus 2 into minus 2 minus 4 plus 2. Okay, and this will be minus minus plus minus 2 minus minus plus 3. So you are getting from here minus 2 and from here plus 1. So this is equals to minus 1. So obviously it is satisfying the relation. So these two results are very very important, and you will be benefited using these two results uh, solving MCQ problems. Okay. So sum of the eigenvalues always represent the trace of the matrix, and product of the eigenvalues represents the determinant of the matrix. Now next topic is eigenvector. Very very important, and definitely you will get at least one question from this topic, eigenvector. And the concept of diagonalization is totally depending on the eigenvector. Okay, so okay, let me tell you one more point. Here I have calculated the characteristic equation using the matrix determinant of a minus xi. This is equals to 0. Yes or no? And since the roots of the characteristic equation are the eigenvalues, and we denote eigenvalue using lambda, that's why in some textbook we use determinant of a minus lambda I. This is equals to 0. Remember, both are correct. If you use determinant of a minus xi equals to 0, if you use determinant of a minus lambda I equals to 0, both are correct. Okay. Ultimately, we have to find out the eigenvalues. So, eigenvector. Actually, what is eigenvector? We know the relation that determinant of a minus lambda I, this is equals to 0. Yes or no? Let's say the matrix is a matrix. Okay, the matrix is a matrix, n by n matrix. Clear? So, and the, let's say lambda is the eigenvalue. Lambda is the eigenvalue. So if there exists an eigenvalue for any matrix A, so obviously there will exist a vector, let's say capital X. I am repeating, if there exists any eigenvalue for any matrix A, so obviously there exists a vector capital X. Okay, this may be a zero vector, maybe non-zero vector. Okay, both are possible, maybe 0, maybe non-zero. So if eigenvalue exists, so obviously this X vector will exist. Now the result is, if you multiply this vector X with our matrix, okay, if you multiply the vector X with the given matrix A, that will be equal to the result lambda into X. Okay, I am repeating, if you multiply the vector capital X with the given matrix A, that will be equal to the product of the eigenvalue and the vector X. Clear? And this vector X, this is called eigenvector. Clear? This vector is called eigenvector. And the value of an eigenvector is totally depending on the value of the eigenvalue. Okay, the value of eigenvector is depending on eigenvalue. Okay, that means if I simplify this equation, we can write that ax minus lambda x, this is equals to 0. Okay, and I have told you x is non-zero, na non-zero, maybe non-zero, maybe zero vector, so we can write a minus lambda I into x, this is equals to 0. Clear? A minus lambda I, this is equals to 0. So this equation is also here in this equation, this vector x, it is our eigenvector. That means when you will have an eigenvalue lambda, you have to satisfy this equation. Okay, then you have to find out the vector x. Okay, you have to satisfy this equation and you have to find out the vector x, and that x will be your eigenvector. Clear? Okay, for any homogeneous system of equation, the determinant of this vector, determinant of a minus lambda I, For an homogeneous system of equation, the determinant of a minus lambda, this is always 0. Okay, so for homogeneous system of equation, x will be non-zero. Okay, x will be non-zero. Why? Because we know that 0 into 0 is undefined. So if determinant is equals to 0, so x must be non-zero vector. Clear? X must be non-zero vector. This is for homogeneous system of equation. So now come to the next topic. Let's come to the example of eigenvector. Question: find eigenvalue and eigenvector of the matrix A is equals to 3 1 minus 1 2 2 minus 1 2 2 0. Okay, find the eigenvalue of the eigenvalue and eigenvector of the matrix this. Okay, let me tell you, this problem will be lengthy problem. Okay, first step is step 1. Step 1 is you have to find out the characteristic equation. Step 2 is solve the characteristic equation and you will get eigenvalue. Okay, step 3 is you have to find out eigenvector for each eigenvalue. Okay, these are the steps. So let's start. First, characteristic equation solution. Characteristic equation means determinant of a minus xi or lambda I. So a minus lambda I, this is equals to 0. So or 3 minus lambda 1 minus 1 2 minus lambda minus 1 2 minus lambda, this is equals to 0. Or if you calculate this, 3 minus lambda into minus lambda into 2 minus lambda plus 2 minus minus 2 lambda plus 2 minus 4 minus 2 into 2 4 minus plus 2 lambda, this is equals to 0. Or 3 minus lambda into, if I simplify this, so you will get lambda square minus 2 lambda plus 2 plus 2 lambda minus 2, and from here 4 cancelled out, so you will get minus 2 lambda, this is equals to 0. So plus 2 lambda minus 2 lambda cancelled. Okay, so what we are getting from this, if I product this factor, you will get, and here you have minus 2, so this is equals to or minus lambda cube plus 5 lambda square minus 8 lambda, and here we have 3 into 2 6 minus 2 plus 4, this is equals to 0. That means lambda cube minus 5 lambda square plus 8 lambda minus 4, this is equals to 0. So obviously this is our characteristic equation. Now you have to solve this equation and you will get the eigenvalues. Okay, so factorization. Okay, here you can see that if I put lambda equals to 1, we are using vanishing method. If we put lambda equals to 1, lambda equals to 1, so obviously we are getting 1 minus 5 plus 8 minus 4. So from here this is minus 4 and from here this is plus 4, so obviously 0. That means lambda equals to 1, this is satisfying the equation. Okay, that means lambda equals to 1, this is the root of the equation. Okay, so obviously you can say that lambda minus 1, that will be a factor of this equation. Okay, so let's solve. One line gap, so this is lambda minus 1. I think you know how to solve in vanishing method. So lambda minus 1, this is cubic equation, so write lambda minus 1 3 times. Okay, now just adjust the this equation, characteristic equation. We have to multiply by lambda square, so this will be lambda cube minus lambda square. We have minus 5 lambda square, so we need minus 4 lambda, so minus 4 lambda square, minus minus plus 4 lambda, but we have 8 lambda, that means we need plus 4, so this will be plus 4 lambda minus 4, this is equals to 0. So we are getting lambda minus 1 into lambda square minus 4 lambda plus 4, this is equals to 0, and this is nothing but lambda minus 2 whole square. Okay, so you are getting lambda minus 1 into lambda minus 2 whole square, this is equals to 0. So this imply lambda equals to 1 comma 2 comma 2. Okay, 1 comma 2 comma 2. So obviously for this matrix the eigenvalues are the eigenvalues are 1 comma 2 comma 2. Okay, that means 1 is a single root or single eigenvalue and 2 is double eigenvalue. Okay, now we have to find out eigenvector for the eigenvalue 1 and for the eigenvalue 2, and here we have two eigenvalues. Okay na, that means am of 2 is 2, that's why we need to calculate the eigenvector only one time. Okay, so first for lambda equals to 1, now we are solving the step 2, that means eigenvector. So first one is for lambda equals to 1. The method is you have to calculate a minus lambda I into x, this is equals to 0. You have to solve this equation, a minus lambda I into x. Lambda means 1 na? That means you have to solve a minus 1 into I, that means I into x, this is equals to 0. You have to solve this equation. So what is a minus I? That means from your original matrix you have to subtract 1 from the diagonal elements. Okay, so this will be 2 1 minus 1 2 1 minus 1 2 2 minus 1, this is your a minus I, and let's say capital X, this is equals to x1 x2 x3, this is equals to 0 0 0. Okay, this is your equation. Okay, let's say this is equation number 1. Now from this equation you have to write the system of equation. What will be the system of equation? This matrix, this is your coefficient matrix na? This is coefficient matrix. We already have learned how to solve system of equation. This is your coefficient matrix. Okay, so what will be the system of equation? 2x1 plus x2 minus x3, 2x1 plus x2 minus x3, this is equals to 0. Second equation again 2x1 plus x2 minus x3 equals to 0. And what is the last equation? 2x1 plus 2x2 minus x3 plus 2x2 minus x3, this is equals to 0. So obviously this is homogeneous system of equation. Okay, this is homogeneous homogeneous system of equation. Okay, and you have to find out the eigenvector. Okay, obviously solution exists, because I have told you for any homogeneous system of equation solution always exists. So first find out the coefficient matrix. 2 1 minus 1, 2 1 minus 1, 2 2 minus 1. Actually in equation number 1, this matrix, this is our coefficient matrix, but the process is first you have to find out the coefficient matrix. That's why I am just following the process. Clear? But I know that this is our main matrix by which we have to get the eigenvector. So now solve the convert this matrix into row echelon form. You know how to solve. So first operation, R2 minus R1 and R3 minus R1. So this is equals to 2 1 minus 1 0 0 0 0 1, and this will be 0. Is this matrix in row echelon form? No. Why? Because here in second row we have a 0 row, but the condition is 0 row must be at the bottom. Okay, so now we have to interchange second row and the last row, R2 R3. So this will be 2 1 minus 1 0 1 0 2 0 0 0. Okay, now you can see that here this matrix is in row echelon form. Okay, this element is pivot element, this element is pivot element, and 0 row is at the bottom, and all the elements above and all the elements below the pivot element are 0. So obviously this is in row echelon form. Okay, now tell me, this will have unique solution or infinite solution? Unique solution or infinite solution? Obviously in this matrix here number of variable is 3, but the number of pivot, that means rank is 2, and when rank is less than number of variable you will get infinite solution. Okay, now tell me, what is free variable? x3 is free variable, na? Okay, so you have to write here x3 is free variable. Okay, x3 is free variable. So the system of equations are 2x1 plus x2 minus x3 equals to 0 and x2 equals to 0. Okay, x2 equals to 0, you are getting a solution. Okay, and you have to take, let x3 equals to k, x3 equals to k. So x2 equals to 0, this is a solution. x3 equals to k, this is another solution. And now x1, so 2x1 plus 0 minus k, this is equals to 0. That means x1 equals to k by 2. So you are getting the solutions: x1 equals to k by 2, x2 equals to 0, and x3 equals to k. Okay, but you need just an eigenvector, so you have to put k is equals to 1. Okay, why k is equals to 1? Because actually we know 0 0 0, this is a trivial solution, but we need some non-trivial solution. Okay, because we are going to calculate an eigenvector, and we know that trivial solution always a solution of any homogeneous system of equation. Okay, so we need a non-trivial solution. That's why we are taking k is equals to 1. You can choose k is equals to 2, k equals to 3, anything. Okay, so if you choose k equals to 1, so what will be the eigenvector? First x1 will be half, x2 will be 0, and x3 will be 1. So this is half, 0, 1. This is an eigenvector of the eigenvalue lambda equals to 1, because this calculation was for lambda equals to 1. Clear? So for lambda equals to 1, the eigenvector is half 0 1. Okay, so using the same process we have to find out the eigenvector for the second eigenvalue 2. Okay, so now for lambda equals to 2, same process, lambda equals to 2. So obviously a minus 2y into x, this is equals to 0. Okay, so a minus 2y means just you have to subtract 2 from the original matrix, so you will get 1 1 minus 1 2 0 minus 1 2 2 minus 2, and this is x1 x2 x3, this is equals to 0 0 0. Okay, so what will be the system of equations? X1 plus x2 minus x3, this is equals to 0. 2x1 minus x3, this is equals to 0, and 2x1 plus 2x2 minus 2x3, this is equals to 0. So the coefficient matrix is 1 1 minus 1 2 0 minus 1 2 2 minus 2. Next step, we have to convert this system of equation into row echelon form. So R2 minus 2R1 and R3 minus 2R1. Okay, so this will be 1 1 minus 1, this is minus 1 no? And 0, this will be minus 2, and this is 1 minus 1 so this is 0 0 and this will be 0. Is this matrix in row echelon form? Obviously yes. Here this is pivot element, this is pivot element, all the elements below the pivot element are 0 and the 0 row is at the bottom, so this is in row echelon form. Now tell me how many solutions will be there. Obviously more than one solution or infinite solution. Here rank is 2 and number of variable is 3, so infinite solution. And what is the free variable? Here x3 is free variable. Okay, so let x3 equals to k. Okay, x3 equals to k. So what will be x? The solution is system of equation x1 plus x2 minus x3, this is equals to 0, and the last one is minus 2x2 plus x3, this is equals to 0. So from here we are getting x3 equals to k na, so x2 equals to k by 2, and what will be x1? X1 equals to x3 minus x2, and what is x3? K minus x2, that means k minus k by 2, so you are getting k by 2. So we are getting the solution that x1 equals to k by 2, x2 equals to k by 2, and x3 equals to k. Okay, so is it correct now? Any mistake? I think this is correct. A minus 2i, what was the original matrix? 3 1 minus 1, yes, this is correct. Okay, so now put k is equals to 1. So the eigenvector is half comma half comma 1. Okay, half comma 1. Okay, now let me tell you one thing. Whenever we are solving the system of equations, when we are getting the infinite solution, we never put k is equals to some fixed value. Now question is why we are putting k is equals to 1 in this eigenvector problem, because here question is find out eigenvector and find out eigenvalue and eigenvector. So just find out one eigenvector for corresponding a eigenvalue. Okay, that's why we need just a single eigenvector. That's why we are putting k equals to 1. Okay, if you write the eigenvector in this form, that k by 2 comma k by 2 comma k, again this is correct. Okay, so now final answer, what are the eigenvectors? So the eigenvectors are for first eigenvector, that was half comma 0 comma 1, half comma 0 comma 1 for lambda equals to 1, and half comma 1 for lambda equals to 2, and this is the final answer. Remember, diagonalization, the concept of diagonalization starts after the concept of eigenvector. Okay, let me tell you just briefly. The diagonal in diagonalization, we have to convert a matrix A in the form of P inverse. Let's say the diagonal matrix is P inverse AP. Okay, and what is this P matrix? This P matrix is called modal matrix. This P matrix is called modal matrix. Okay, and what is modal matrix? Modal matrix means just you have to write the eigenvectors column wise. Okay, that means here the eigenvectors are half 0 1, so this will be half 0 1, and half 1 half 1. Okay, in this way, just in this way you have to find out the modal matrix P, then find out the P inverse and product of P inverse AP. That will be your diagonal matrix, and this is the concept of diagonalization. Okay, so in my next lecture I will complete the total concept of diagonalization. So I think in this video the concept of eigenvector and eigenvalues are clear. Now you can solve your previous year question papers and question bank. If you have any doubts, then comment me in my comment box, or you can send me message on my WhatsApp number. Thank you.